Very, very good morning, everybody. Hope you are doing well and enjoying the daily classes that are happening. So today we are going to discuss about structural isomerism. Yesterday we have seen what is the meaning of isomerism. We have still not started with the classification of isomerism. And I also told you yesterday that how we can draw total number of structural isomers for any given formula. For any given formula, how do we draw total number of isomers? Few questions we have done. More will keep coming in this lecture. Okay. Good morning, Prashant. Good morning, everybody. Mohit, good morning. Atma, Kuru, Puneet. Okay, guys. So we studied about what is the meaning of isomerism, what are homologues, what are isomers, what is the difference between them. Then few questions we have done from this particular topic. These questions we'll be dealing with at the end of the class. I'll tell you their answers. Okay, their answers will come at the end of the class. So let us start with classification of isomers. See, whenever you see any two isomers, two molecules with same molecular formula, first you ask them a question. Are your structures also same? That is the question I'm asking. Isomers, are your structures same? Okay. Are your structure same? By structure we mean to say how when you write the molecule on the page, on a notebook, whether they are looking different or not, structural wise. If they say, no, our structure is different. No, our structure is different. Then we will call them as structural isomers. Okay. Then we'll call them as structural isomers. So what is the definition of structural isomers? Compounds with same molecular formula. Same molecular formula but different structural formula. Okay, compound with same molecular formula and different structural formula. Beta, how do you come to know any two people are structural isomers? They will have different name only. Name will be different. 2-methyl heptane, 3-methyl heptane. But-1-ene, but-2-ene. Pentanone, pentanol. Completely different names will be there. Okay, so that is structural isomer. So what are, keep writing everybody. You can draw this and start writing structural isomers. Structural isomers are compound with same molecular formula but different structure. Same molecular formula but different structure. Good morning, Niranjan. Good morning, Human. I hope all of you are ready with your pen and books and start writing it. Okay, start writing it. Compounds with same molecular formula but different structure. Okay. But if they had answers, yes, our structure is same. Yes, our structure same. Our structure is same. Then what do you say? Then you say, please stand up. Because when you are lying on the notebook, I am not able to see any structural difference. Okay. When they are lying on the notebook, you are not able to see any structural difference. Then you ask them to please stand up. Okay. Then you say, okay, please stand up. Once they stand up and come in 3D, 3-dimension, then you see, oh, their structure was same, but their spatial arrangement of the groups are different. For example, when I take but-2-ene, when but-2-ene is written on the notebook, but-2-ene feels like this molecule and this molecule. Let's say these two molecules I have written on the notebook. Both the molecules are looking exactly the same. Okay, so when they are written on the notebook, they say our structure is same, but I checked their boiling point. This was having high boiling point, lower one was having lower boiling point. Then how do two people with same structure have different properties? Means they are not same compound. They are different compounds. They are isomers. So when you ask them to stand up, when he stood up, when the first one stood up, it was a cis isomer, means both the methyls were on the same side of the plane. Whereas when the second one stood up, there it was both the methyls arranged opposite to each other. So then we came to know, okay, when they stand up and we look at them in 3D structure, then they look different. So what is a stereoisomer? Stereoisomers are compound with same molecular formula, as well as same structural formula. Structure also same, but different arrangement of groups or atoms in three-dimensional space. Stereo means space only. Okay, stereo means space only. So we can call them as stereoisomers, 3D isomers, space isomers. Is it clear to everyone? Yes or no? What I just told you. Is it clear? The definition? Is the definition clear to everybody? Is the definition clear to everybody? So what is going to be the definition of stereoisomers? Write it down. Compounds with same molecular formula, same structure, but different spatial arrangement. Of groups. That is what we call as stereoisomers or space isomers. So today our concern is only to talk about the structural isomers. Stereoisomers is a little long topic. We'll be talking mostly about the important part of the stereoisomers, not the whole thing. So today our aim is to talk about structural isomerism. Okay. So structural isomerism further is of so many types. You can ask them, okay, your structure is different. What is different in your structure? If they say our parent chain is different, they will be chain isomers. If their parent chain is different. Okay. So when parent chain will be different, then their word root will be different. Yes or no? Because parent chain notifies the word root, which is how many carbons are there in the parent chain. So if they have different number of carbons in parent chain, everything else same, but different number of carbons in the parent chain, we'll call them as chain isomer. Butane, 2-methyl propane, both are going to be same. We'll see the examples. Position isomers. When they say our parent chain is same, but position of functional group or position of unsaturation or position of any substituent is different. We'll see the example. 1-chloropropane, 2-chloropropane. 1-chloropropane, 2-chloropropane are going to be position isomers. Ring chain and functional isomerism are same only. Okay. We'll see what is the meaning. Functional isomerism means they have different functional groups. For example, I showed you yesterday, alcohols and ether shows functional isomerism. Carboxylic acid and ester shows functional isomerism, and so on. Ring chain also I'll explain between the class. Metamerism will see separately. Tautomerism also will see separately. These are some special type of isomerism. So let us start with our first one. All of you can start writing. Structural isomers. First one, which is going to be chain isomers. Quickly write down, everybody. Chain isomers. So these are, quickly write down, compounds with the same molecular formula. but different number of carbons in parent chain. Different number of carbons in parent chain. Okay. Now I ask you a question. Can you tell me the smallest alkane which can show chain isomerism? Can you tell me which is the smallest alkane which can show chain isomerism? Think and tell quickly. I need the answer in the chat box. Smallest alkane which shows chain isomerism. That's correct. That's correct. Human has given the correct answer. Can everybody give me the answer? Yes, correct, human. No, Niranjan, propane cannot show. How propane will show? C4H10. Yes, butane will show. Not propane. Ramakrishna, not propane. Butane will be the answer. Okay? Butane will be the answer, beta. When you see one carbon, CH4, it though cannot show chain isomerism. When I take two carbon, again, I cannot have any other way to write a ethane. Ethane can only be written like this. No chain isomerism. When I write propane, CH3, CH2, CH3, propane, what other way is there to write? There is no other way, no? 3 carbon can only be written in a straight chain only. You can't have any branching. So, no, it can also not show any chain isomerism. No. Yes, it will start from butane. Butane will show chain isomerism. So, butane has 2 chain isomers. You can just see here. Butane, which is, I can keep all the 4 carbons in a straight line. Or what I can do is I can cut the chain to 3 carbon and put a methyl on second number like this, 2-methyl propane. So remember it's butane has 2 isomers and their relation between the 2 isomers is they are chain isomers of each other. As the first one has word root but, second one has word root prop, 2-methyl propane. Okay, so their word root is different. Here but, here prop. Its common name is isobutane. Please remember this. Its common name is isobutane. Yes. And its common name is normal butane, N-butane. But they are not the IUPAC names. They are just common names. Now my question to you is, how many isomers of pentane? This is the next question. C5H12, how many structural isomers? Quickly, pentane. For a pentane, how many structural isomers you can get? And then we will try to see the relation between them. Cherry says 3. Good, all of you try. Human says 3. And now, after doing it once, 3 or 4, no, 3 only, human. Okay, draw them. All of you draw them. Draw the 3 and name the 3 quickly. Within the chat box, quickly answer their names. What are their IUPAC names? Quickly. Type fast. What are the IUPAC name of the 3 that you are getting? Niranjan is getting 4. Niranjan, you tell me which 4 you are getting. If Niranjan, you are getting 4, you tell me which 4 you are getting. Purna Tej is getting 3. 3 is correct. Whenever you write isomers, no, and you feel that you are getting 4, but answer is 3, try to name all of them. Try to name all of them. Once you name them, you might have written something repeated. So by naming them, both of them will have same name. That means you have repeated it. Yes. So IUPAC name I am asking, beta. It is going to be pentane, which is 5 carbon straight chain. 1, 2, 3, 4, 5. Then there will be a methyl butane, means I'll cut the chain to 4 carbon, parent chain cut to 4 carbon. Now I have to keep 1 carbon extra as a methyl. I cannot keep it here and here because otherwise it will become pentane only. Whether I keep the methyl here or I keep the methyl here, both will be same only, 2-methyl butane. Okay, both are same, here or here, your wish. Okay. So this is the second one. So with a 4-carbon chain, there is only one possibility possible, which is 2-methyl butane. Third is with a 3-carbon chain. With a 3-carbon chain, now 2 carbons are pending. Those 2 carbons can attach like a ethyl. You might say, sir, they will attach like a ethyl, 2-ethyl propane, but this is not 2-ethyl propane, beta. You are not doing the naming correct. It is actually again the same thing as before. It is a 2-methyl butane only. So there is no possibility of 2-ethyl propane. Such a thing cannot exist. That is a wrong way to do, right? So ethyl we cannot attach. So we should attach 2 methyls. Both the methyls will come on second position only. 2,2 dimethyl propane. 2,2 dimethyl propane. Okay. So IUPAC name are pentane, 2-methyl butane, 2,2 dimethyl propane, and their common names are N-pentane. Remember it. Whenever you see this V shape, it is isopentane. And this is neopentane. So answer is 3. Answer is 3. No, beta, I cannot explain in Telugu. I don't know Telugu. S-Craft World. You can stop chatting now. Okay. Hi, Vani. Is this clear to everyone? Now, can you do for hexane? Can you do for hexane? Can you tell me how many isomers will be there for hexane? Hexane, C6H14. Structural isomers. So beta, as you can see here, all 3 of them are going to be chain isomers to each other. So pentane has 3 isomers and relation between any of 2 of them is chain. These 3 have different chains. First and second are chain isomer. Second and third are chain isomer. First and third are also chain isomers. Okay, so 6 carbons, there are 5 possibilities. Yes, there are 5 possibilities. Let us draw them. And then we will move on to the next type of isomerism. Okay, next type of isomerism. 6 carbon, how should we draw? We should draw all 6 in the straight line. Hexane. Hexane. Then we should cut the chain to 5. Now, when you cut the chain to 5 beta, there are 2 places you can keep the methyl. There are 2 places you can keep the methyl. You can keep the methyl on second number, which is 2-methyl pentane. 2-methyl pentane. Or you can also have another position isomer of it, which is 3-methyl pentane. 2-methyl pentane and 3-methyl pentane. They are not chain isomers. They are position isomers because the chain is the same, 5-carbon chain. So this is 2-methyl pentane. This is 3-methyl pentane. Okay, they are position isomers to each other as the name itself tells you. Beta, do not call it as neohexane, isohexane. Okay, do not call it as neohexane, isohexane. There is no isoneo used for a hexane. Okay, there is no isoneo common naming for hexane. There is no such name. This is hexane. This does not have a common name. It is 2-methyl pentane, 3-methyl pentane. Now, cut the chain to 4. Butane, 1, 2, 3, 4. When I have butane, in a butane, first I'll try to keep the longest alkyl, means a ethyl, 2-carbon ethyl. But I can't keep it. If I keep a ethyl here, actually it is becoming now again pentane, 5-carbon chain. So I should not keep a ethyl. I should keep 2 separate methyls. 2 separate methyls. I can keep both of them on second number, 2,2-dimethyl butane. Or if I keep them here also, it's same only. Or I can keep them separately at number 2, at number 3. So this is going to be 2,2 dimethyl butane. This is going to be 2,3 dimethyl butane. Okay, clear? So this is the one. So total 5 isomers we are getting. Cutting the chain to 3, always keep trying. If I cut the chain to 3 more carbons are remaining. If I keep one ethyl here, one methyl here, it is actually same as this compound only, if you see. If you draw something like this. So do not call it as 2 ethyl, 2 methyl propane. It's not that. It is actually now a 4-membered ring. So it is a 2,2 dimethyl butane only. Okay. Yes. So answer is, these are the 5 possibilities we have. So answer is 5. I hope it is clear to everybody that how do we draw the isomers? How do we draw the isomers? Okay. Now, next we'll talk about what is position isomerism. I'll ask you a few good questions from here. You need to answer them. Position isomerism. So here, parent chain must remain same. Parent chain must remain same. What should be different? Different should be only the locant of a substituent. Locant means position only, no? 2-methyl, 3-methyl, 4-methyl, 5-methyl. These are all different locants. So substituent, functional group or unsaturation should have a different position in the parent chain, but parent chain must remain same. Okay. So positional isomerism, write it down. Compounds with same molecular formula, same parent chain, but different position of functional group, unsaturation or substituent. Different position of functional group, unsaturation or substituent. I'll ask you a few questions now. Okay, one example I'll show you first. So let us see example where functional group has a different position. Functional group has a different position, like if I take butane 1-ol and butane 2-ol. Okay, butane 1-ol, butane 2-ol. Both of them obviously have same parent chain, but position of functional group is different. Maybe position of unsaturation is different, something like this. Okay, if you try naming them, these two cyclic compounds, if you try to name them, this is going to be named as 1, 2, 3, 4, 5, 6, 1,3-diene. Cyclohexa 1,3-diene. But this is going to be 1,4-diene. 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 Like that. Okay. So a cyclohexadiene can be of these types. 1,3-diene also possible. 1,4-diene also possible. Okay. Like this we are going to talk about functional isomerism. Now the question to you is, which is the smallest alkane to show positional isomerism? Quickly tell me. Smallest alkane to show positional isomerism. Next question is smallest alkene to show positional isomerism. Quickly tell me both the answer. Yes, Sindhu. They can also be examples. So many examples can be there. I have just written 2 examples. smallest alkane to show positional isomerism? See, that's where you don't think. You just start answering. Beta, how butane will show positional isomerism? You tell me. How butane will show positional isomerism? Tell me. Butane has two isomers, you saw. Butane and isobutane. How butane will show isomerism? You tell me. This was butane, na beta. Butane and 2-methyl propane. They are the chain isomerism. They are not positional to each other. So butane does not have any isomers which can be called as position isomers. Butane only can show chain isomerism. Butane can only show chain. Butane has two options, butane and 2-methyl propane. What are they to each other? They are related as chain isomers. So we cannot see any position changes here. Position cannot change. Pentane pe position starts. On pentane, positional isomerism starts. No, pentane also does not. You see here, pentane is pentane, 2-methyl pentane and neopentane. They are also chain, no position till now. Positional isomerism starts from hexane. In hexane, you can have 2-methyl pentane or 3-methyl pentane. So till the time you have 6 carbons, you can't have position isomers. Below 6 carbons, position isomers are not possible. Methane, ethane, propane, butane, pentane. Where is the different positions you can have? Can you have 3-methyl propane? No, it's only 2-methyl propane. So I cannot have any position isomer here. Here it is 2-methyl butane. Can you have a 3-methyl butane? No, not possible. Only 2-methyl butane is possible. So no position isomerism here, no position. Only chain is working. See here. These two are what? These two are chain isomers. These three are what? They are chain isomers. Now, in hexane, these two become positional isomers. These two also become positional isomers. Means position isomerism starts from hexane. Is it clear? Please tell me quickly. These type of tricky questions can come in NEET. We have to think carefully in those. You have to think carefully in those questions. Hexane will be the smallest. Please tell me, is it clear? Before hexane, no alkane has positional isomerism. Only hexane will start having positional isomerism. Pentane, no, not pentane. Can you see any position isomers in pentane? Beta, which alkane shows positional isomerism? Means you draw all the isomers of the alkanes. Methane, no isomerism. Ethane, no isomerism. Propane, no isomerism. Butane, yes, it shows 2 isomers. But what kind of isomers are they? They are chain isomers. So butane is not showing any positional case. No, is there any positional case here? There is no position isomer case. So butane, wrong. Pentane. Pentane shows isomerism. Which type? Pentane can become 2-methyl butane. Can it become a 3-methyl butane? No, this is only 2-methyl butane possible. It becomes 2,2-dimethyl propane. All three are chain only, na? 5-membered ring, 5-membered chain, 4-membered chain, 3-membered chain. Chain, chain, chain. There is no positional case possible. Hexane. Okay, so pentane also not possible. Hexane, yes. 6 carbon, straight chain. 5 carbon with a methyl, 2 options in position. Position number 2, position number 3. So position starts here. Position starts here. Amala, is it clear? Everyone, is it clear? Yes or no? Was it tricky? If it was tricky, write tricky in the chat box. If it was tricky for you, write tricky in the chat box. Next time, don't try to answer fast. Try to draw and check. I can give you 5 minutes for a question also. I don't have a problem in giving you 5 minutes for a question as well. All the questions that I'll ask are not going to be straight away answers. Are not going to have straight away answers. Is this clear? Yes or no? Please mention clear. So answer is hexane. Please remember. Hexane. So in hexane, first time position isomers come when you get 2-methyl pentane and 3-methyl pentane. Okay. Positional isomerism in alkene. In alkene. Positional isomerism in alkene can start from how many carbons? Tell me. In alkenes, positional isomerism can start from how many carbons? They can start from, see, first one is ethene. Ethene cannot have any other position. Ethvanine, one only possible. Propene also prop-1ene only, no other possible. But butene can be butene, 1 or 2 butene. 1 butene, 2 butene. So butene will be the answer. Smallest alkene is going to be butene. It can show but-1ene and but-2ene. So answer is 4 carbons are required. Yes, butene. Good. Clap for yourself. If you have done it correct, good. Clap for yourself. Next question from position isomerism. All of you carefully tell me. Okay. Be careful while answering. Next question is, how many positional isomers are possible for, how many positional isomers are possible for, first one, first tell me, dichlorobenzene, second one for trichlorobenzene, and next one for trichlorocyclohexane. Carefully do it carefully. Okay. Dichlorobenzene, trichlorobenzene, trichlorocyclohexane. I am asking how many positional isomers are possible. Don't try to change the chain and all. I am not asking how many total isomers are possible for C6H3Cl3. No, I am not asking that. I am asking a simple question. I have given you that the name of the compound is dichlorobenzene. How many types of dichlorobenzene are possible? 1, 1, 1, 2, 1, 3, 2, 4, all those types. So to tell me how many. Divik says 3. Good Divik, good human, good Sindhu. Good, that is correct. What about trichlorobenzene then? For dichlorobenzene, you are saying 3. 3 is correct. Sharanya also correct only. Ortho, meta, para. Ortho dichloro, meta dichloro, para dichloro. These are common names. Or 1, 2 dichloro, 1, 3 dichloro, or 1, 4 dichloro. Yes, Lakshmi Priya, 3 is correct. So we can have a benzene ring. I hope all of you know that on a benzene ring, each carbon can have only one substituent, not more than one. You can't keep a 1, 1 dichloro, okay? Because carbon will have 5 bonds otherwise. So keeping one chlorine fixed, I say one chlorine, you sit here. Other chlorine position, I'll keep changing. So 1, 2, 1, 3, 1, 4. 3 are possible. Try also 3. Very good, Lakshmi Priya. Very good, Niranjan. Very good, Cherry. Very good, human. 3. A3. B also 3. Try also 3. Yes. Try also 3. So this answer is 3 isomers. What about trichlorobenzene? How many possibilities for a trichlorobenzene? Okay. This was 1, 2 dichloro, 1, 3 dichloro, 1, 4 dichloro. Now let's make one more benzene. Now 3 substitution we have to do here. 1 chlorine, you fix it. Chlorine, you sit on the top. 1 chlorine is fixed. Don't change his position. Don't change his position. Okay. Now, Next two chlorines can be like this, can be like this, can be like this. Next two chlorines can be next to each other. 1, 2, 3. Okay. Keeping one chlorine fixed, next chlorine can be ortho to each other. Correct. Next chlorine can be meta to each other. Like this. Okay. This is one possible. All of you can see here carefully. Don't do mistake. Can you tell me the names of the three you got? Can you tell me the names of the three compounds of the second one? Numbering, can you tell? 1, 2, 3, 1, 2, 4, 1, 2, 5. Okay, so Sharanya has given the correct answer. 1, 2, 3, 1, 2, 4, 1, 3, 5. 1, 2, 3, 1, 2, 4, 1, 3, 5. Very good. So you can get 1, 2, 3. So I can think of keeping two chlorines together. I'll say two chlorines you stay together. Now third chlorine can come here or here, but both will be same only. 1, 2, 3, 1, 2, 3. So any one I can draw. Third can come here. 1, 2, 3. Keeping two chlorines together, I just showed you that these two positions were same only. This position and this position were same only. These two positions are different. So I can keep the third chlorine here or here, but both will mean same. You see here, if I keep the third chlorine here, naming will be 1, 2, 3, 4, 124. 124. Even if I keep it here, now also it is 124 only. Now the numbering will start from this side. 1, 2, 3, 4. This is also 124. So 124, 124. So one of them is 124. So keeping two chlorines together, I have two options, 123 and 124. Now I have to say you two chlorine also need to separate, go away from each other. So when the two chlorines go away from each other, the next third chlorine, if I keep it here, again it is 124 only, na beta, 1, 2, 4. So the only unique possibility is 135. 135, which is this one. So 1, 2, 3 trichloro, 1, 2, 4 trichloro, 1, 3, 5 trichloro. Yes, good. What about the third one? Manideep says third one has 3 answers. Human says third one has 3 answers. Anybody else? Anybody wants to change the answer of third one? Trichlorocyclohexane. Trichlorocyclohexane. 3. Lakshita says 3. Amala for VAIDYAH. Yes, can you tell me? Trichlorohexane. Beta, in trichlorohexane, this is not benzene, this is hexane. Means one carbon can also get 2 chlorines. One carbon can also get 2 chlorines. No. So you did wrong. Many possibilities will be there. See here. One carbon can also get 2 substituents. There is no pi bond inside now. Are if you got trapped here, please mention trapped in the chat box. Please mention trapped in the chat box. Answer will not be 3. Answer will be more than 3. So I can have 1, 1, 2, 1, 1, 3, 1, 1, 4, 1, 1, 2, 1, 1, 3, 1, 1, 4. And 3 extra these type. 1, 2, 3, 1, 2, 4, 1, 2, 1, 3, 5. 1, 2, 3. 1, 2, 4, 1, 3, 5. Just like benzene you did, same you can do for here as well. So there will be 6 answer. Answer will be 6. Beta, be careful while doing these questions. Okay. Isomerism questions are the ones. Be careful. Many new questions I can form and give you. Okay. Any question can be asked in NEET where the isomers are below 10. This year they asked 10. Generally they did not ask 10 also ever. Maximum they have gone till 8-9 isomers. But this year they asked the question with 10 isomers. So we can go for all these difficult conditions. Nothing else will be possible. So in a cyclohexane, 1 carbon can get 2 substituents also. So 3 extra cases we are getting. 1, 1, 2, 113, 114, 115 not possible, 116 not possible. They will become previous cases only. Or 123, 124, 135. Okay. Is it clear? Yes or no? Clear? Is this question clear to everybody? Clear or not clear? If you are MPC, JEE will ask these questions very easily. These are JEE mains type of questions only. Is it clear? Clear? Yes. 135 not possible. Possible no beta. This is 135 only. This is 135 only, na? 135, 124, 123, 114, 113, 112. I'll give one more question. Okay, I will give one more question. But while attempting it, be careful in attempt. Be careful in attempt. Okay. So, next question is, which of the following is correct relation between compound A and compound B? Option 1, they are chain isomers. Option 2, they are positional isomers. Option 3, they are identical. Or option 4, they are functional isomers. This is a NEET PYQ. Prashant says chain, Sindhu says chain, Narsimha says functional. Niranjan says chain. Yamini Priya says chain. Chain. All are saying chain. Clap for yourself. Again, you got trapped. Answer is position. Answer is position. Answer is not chain. What was the first thing I told you in the class today? Whenever you get two isomers, how do you know what type of isomers they are? You should name them first, beta. You should name them. Did you name these two? Did you name these two? Can you name it now? Name and then think. I will not tell. Name and then think. Siva is correct. Again got trapped. Chandana Shri correct. Name them. Divik. Can you name them, Divik? Can you choose the parent chain and name? How do we name ethers? Ethers are functional group without any surname. So we take the longest carbon parent chain. 1, 2, 3. Here 3 carbon parent chain. 1, 2, 3. Here also 3 carbon parent chain. Here also 3 carbon parent chain. So both are propane. This is also propane. This is also propane. Number them. 1, 2, 3. 1 methoxypropane. It is 1 methoxypropane. Here when I number it, 1, 2, 3, 2 methoxypropane. 2 methoxypropane. Got trapped again. Yes. Be careful. Are you learning something new today? Are you learning something new today? Just type new in the chat box with a smiley figure that you are getting trapped in every question. Write new in the chat box. And like the video before we move forward. Then I'll give you more interesting questions like this. Okay. Sharanya. Good. So these are the types of questions you can get from just position isomerism. So many different questions you have seen from the position isomerism itself. Okay. All right. Now let's go to the third one, which is functional isomerism. Functional isomerism. Third one is functional isomerism. Most important is this one only. Most important is this one. So maximum questions come from functional and position. And when we study position, metamerism is also kind of a positional isomerism only. So meta, position, function, these are the main ones. Okay. Anyways, any question will come, you'll be able to attempt it, but be very careful while attempting the question. That's what I'm saying. Okay. So next one, functional isomerism. Compounds with same molecular formula, but different functional group. Okay, here parent chain and all, nothing you have to see. If functional group is different, directly call them as functional group isomers. Okay, nothing you have to see, no position, no chain, nothing. Just functional group should be different. Now, which all functional groups are there which can show functional isomerism? Examples of functional groups. I'll ask you, tell me, if I have an alcohol, who else can show functional isomerism with alcohol? Alcohol and, tell me, alcohol and. So to check functional isomerism, you should have same number of heteroatoms and same number of pi bonds. So in alcohol, there is one oxygen but no pi bond. In the same way, ether also has one oxygen and no pi bond. So alcohol shows with ether. Yes, correct. Open chain alcohol shows with open chain ether. For example, if I have propanol and methoxyethane. Yes, so keeping the carbons and oxygen same, I can draw alcohol and ether. Then tell me, if I have a aldehyde, who else will have same formula as the aldehyde? Who can show functional isomerism with the aldehyde? Tell me, aldehyde. Aldehyde, which has one oxygen, one pi bond, it can show with ketone, one oxygen, one pi bond. And it can also show with cyclic ethers. Cyclic ethers also can be formed. Yes. And cyclic alcohols can also be formed. Cyclic alcohols. See beta, aldehydes have one oxygen and one unsaturation, which is pi bond, O and a pi. Now instead of O and a pi, you can keep a O and a ring. O and a ring means cyclic ether. I'll show the example. Very important. This year example only I'm telling. You can also have a cycle plus OH. So I need one unsaturation and one O. Unsaturation and a O can be pi bond and a O. Double bond O, double bond O. Can be a cycle and a O. Cyclic ether. That can be a cyclic alcohol also. For example, let me show one simple example to you. Okay. For example, if I have 3 carbons aldehyde, 1, 2, 3. 3 carbons aldehyde, 3 carbons ketone. You can see here I am writing the hydrogens also. CH3, CH2, CHO, CH3, CO, CH3. Now if I take a cyclic ether may look like this. CH2, 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 O, like this. You can see here that there is one unsaturation which is in the form of cycle and one oxygen. Still the formula is same only now. Still the formula is same only. C3H6O. I can take a cyclic alcohol. Let's take a cyclopropanol. This is cyclopropane and a OH here, cyclopropanol. This is also C2H6O. C3H6O, sorry. Many can be there. I have written just 4 examples. You can have other functional group also, but let's not write it here. Enol can also come. Enol. So one pi bond and one O you need. Okay. So these are the ones, etc. you can mention here. Other things also can be there. Okay. Other things also can be there. Now tell me, RCN and RNC will also show. All of you know can see this. RCN and RNC, they will also show functional isomerism. 4th one you can mention, primary amine, secondary amine, and tertiary amine. Already we have done the examples in the previous class. Primary, secondary, tertiary amines are also considered to be different functional groups. Please remember. A primary amine is a different functional group. A secondary amine is a different functional group. A tertiary amine is considered as a different functional group. So we saw the example of C3H9N. We got primary also. We got secondary also. We got tertiary also. These are also functional isomers. 5th one. 5th one. You should remember a alkene and a cycloalkane. Alkene and a cycloalkane. This is also a functional isomerism, but it has a special name. Its name is ring chain isomerism. Ring chain isomerism. So ring chain isomerism is a special type of functional isomerism only. Ring chain isomerism is a special type of functional isomerism. Okay, is another form of functional isomerism. Whenever there is an alkene, alkene has a different properties as compared to a cycloalkane, but their formula will be same only, like we did in the last class as well. Okay, so when I take a 4 carbon alkene, butene, and I take a 4 carbon ka cycloalkane, cyclobutane, both will have different properties. So we'll call them as one ring, one chain, ring chain isomerism, or it is also called as functional isomerism. Okay, ring chain or functional isomerism. Okay. Up to here, everything clear? Yes or no? Many more can be there. I am not writing them here. You can write one more, ester and acid. Esters and acids. Esters and acids. esters and acids. For example, if I take a 2-carbon carboxylic acid, I can take it like this: CH3, CH2, C double bond O, OH. 3 carbons let me take. So 3 carbons carboxylic acid, I am taking propanoic acid. Now I can make it an ether by just sending some alkyls to that side after oxygen. So I'll bring hydrogen here. I'll send methyl there. So this became methyl ethanoid. Methyl ethanoid. And this is propanoic acid. Propanoic acid. So these are the functional group which you can learn, which will show functional isomerism. Is it clear to everyone? Quickly tell me. Up to here clear, so that I can give you some questions. Is the functional isomerism examples clear to everybody? Can I give you some questions now? Okay. So the question to you is, first question, what is the relation between this one? What is the relation between this one? This is A, this is B, this is C, this is D. Options are, first option, A, B are position isomers. A, C are identical. A, B, C are identical. C, D are position isomers. C, D are functional isomers. Multi-option correct it is. Multi-option correct. Choose more than one option. Divik says 3 and 5. You can remove the second option. If third option is there, you can remove the second one. You can remove the second option, no problem. Yes, so 3 and 5, that is correct. A and B are positional isomers. Answer is no. Both of them are a ketone only, no? First one is butane 2-one. Second is also butane 2-one. So butane 2-one, butane 2-one. A and B are same only. C is also same, butane 2-one. So A, B, C are identical. A, B, C are identical. C is a ketone, but D is a aldehyde, because double bond O at the corner means aldehyde. This is a ketone. So C and D are functional isomers. C and D are not position. So option 3 and 5 are correct. 2, 3 and 5 are correct, or 3 and 5 are correct. That is absolutely fine. Okay, next question, question number 2. Be careful and do this one. How many structural isomers for compound C7H8O containing a benzene ring? Containing a benzene ring. Think how you will do. I told you how to do these type of problems in the last class also. First find the degree of unsaturation. First find the degree of unsaturation and then try solving it. How many structural isomers are possible for C7H8O containing a benzene ring? Containing a benzene ring. A benzene ring is a must. Think and do. DU4, Sindhu, correct. DU is coming 4. Whenever DU comes 4, means all the unsaturations are present in benzene only. All the unsaturations are present in benzene only. Benzene itself has 4 unsaturations, 3 pi bonds and 1 ring. So, outside of benzene, I can't keep a pi bond, but I need to keep oxygen. So, I have to make alcohols and ethers only. I have to make alcohols and ethers only. So, try how many alcohols, how many ethers can you get with C7H8O? Alcohols and ethers only have to make. Nani says 3. Finally, Nani is studying something, but Nani answer is incorrect. Manideep says 3. Manideep, think more. Manideep, you are an intelligent student, I know, but you need to think more. Amala, what is DU? Degree of unsaturation, Amala. Please watch yesterday's class. Sindhu says 4 alcohol. Divik says 4. Can you think more? Can you think more? Can you ask your brain to be a little more active? Or you are stopping at 4? See here, I'll show you how many are possible. First thing, DU. Degree of unsaturation, formula was carbon plus 1 minus hydrogen by 2. Because halogens and all are not there, I'll just use this formula. 7 plus 1 minus 8 by 2. 8 minus 4, 4. 4 represents a benzene ring only. 4 represents a benzene ring only. 5 are possible. Sindhu, good. So first I'll make a benzene ring. So 6 carbon are already satisfied. 6 carbons are already satisfied. Now my concern is just to satisfy one more carbon and one more oxygen. Carbon and oxygen. 7 carbons are there. Don't worry about hydrogens. Do not worry about hydrogens. Hydrogen will automatically balance. I need one more carbon and one more oxygen. So if I keep an oxygen here as an alcohol, it's a phenol, not an alcohol. It's a phenol. If I keep a OH here, then there are 3 positions to keep methyl. I can keep a methyl on number 2, number 3, number 4. So these are 3 cresols I can make. Orthocresol, metacresol, paracresol. So I can keep the O and C separately, that O you remain somewhere else, C you remain somewhere else. Then you say to them, you stay together on same carbon. You say you stay together on same carbon. Means I can make a benzyl alcohol, CH2OH. This and this are functional isomers. They are not position or anything. They are not chain. They are functional. It is a functional group phenol. It is a functional group alcohol. So alcohol and phenol can also show functional isomerism. Alcohol and phenol can also show functional isomerism. Functional isomers, these two. And whenever there is an alcohol possible, there is always an ether also possible. Any sol, yes, that's correct. You can say oxygen, you come first, then carbon will come. OCH3. OCH3. This is any sol. They are also functional isomers. They are also functional isomers. Whereas these three are positional isomers. First three are positional isomers. These three are positional isomers. Okay. So cresol and benzyl alcohol are functional. Cresol and benzyl alcohol are functional. Cresol and anisole also functional. One is a phenol, one is a ether. And these two are also functional. 5 is the answer. 5 is the answer. If everything clear up to here, please mention a crystal clear in the chat box so that I know it is clear to you. And please like the video. One more question we are going to discuss today. One more question we are going to discuss today. You need to think and tell me the answer. C5H8, how many alkynes are possible? How many alkynes are possible for C5H8? Only alkynes. Someone says 3. Sharanya says 3. Can you write the name of the 3 that you are telling, beta? Three. Okay. So 3 you are telling me. Let us see the 3 that you are making. First, longest chain of 5 carbon. I can keep a pent 1 ion, or I can make a positional isomer of it, which is pent 2 ion. Pent 1 ion, pent 2 ion. Then, you know, pentane can be pentane, isopentane, and neopentane. This was pentane. In pentane, 2 positions are possible for ion. Pent 1 ion, pent 2 ion. Now let's make a isopentane. This was isopentane. In a isopentane, obviously I can't keep a triple bond here. This is not possible. I can't keep a triple bond here. It is not possible. But I can keep a triple bond here. So this is the third one. And then there was a neopentane. Neopentane was this. But in a neopentane, there is no possibility of keeping a alkyne because carbon cannot satisfy that many valencies. So answer is 3. Answer is 3. Now your homework is little long one. Find total structural isomers for C3H6O. Okay, give it time. It will take little bit time. It is a difficult question. It is a difficult question. So give it time. C3H6O, I want you to tell me total how many structural isomers you are able to get. Okay, that's all for today. Bye bye. Thank you. And I'll see you all in the tomorrow's class with the tautomerism remaining. And tautomerism we'll be discussing tomorrow. Okay, only tautomerism. Bye bye.